54 from Chapter 14. We're asked to calculate the H3O plus concentration, and we're supposed to label the solution as acidic, basic, or neutral. So I've highlighted some key points here in green. We're going to use this equation here. The auto-ionization constant for water is 1.0 times 10 to the minus 14th, and that's equal to the two concentrations times each other. We'll figure out if the solution is neutral, basic, or acidic by comparing the two concentrations. If hydroxide and H3O plus concentrations are equal, it's neutral. If the hydroxide concentration is higher, it's basic. If the H3O plus concentration is greater, it's acidic. So for this first problem, H3O plus is given to us as 3.4 times 10 to the minus 9. And so we want to calculate what the hydroxide concentration is by solving this equation for OH minus. And that's equal to Kw over H3O plus. And that's going to be equal to 1.0 times 10 to the minus 14 over 3.4 times 10 to the minus 9. And we get the quantity 2.9 times 10 to the minus 6 molar. Check your calculator to make sure you're getting the same kind of thing. Some calculators are tricky. So this is the hydroxide concentration. This is the H3O plus concentration. The hydroxide concentration is greater, so we would therefore label this as basic. All right, basic solution. Here we have hydroxide, so we have the other concentration. We take the formula for the ionization of water and we solve for H3O plus, and that's equal to Kw over hydroxide. Okay, and that's equal to 1.0 times 10 to the minus 14 divided by 0.010, and the number we get on our calculator needs to be expressed to 2 sig figs, so we get 1.0 times 10 to the minus 12 molar. Okay, so clearly the hydroxide concentration is greater, so we would call this basic as well. Okay, once you see the pattern here, I urge you to pause the video and check your own answers against what I'm showing here. So here we want to again calculate H3O plus by solving for the H3O plus, and we get Kw over hydroxide again, and so that's 1.0 times 10 to the minus 14 divided by 1.0 times 10 to the minus 10, and again to 2 sig figs we get a value of 1.0 times 10 to the minus 4. It looks like H3O plus concentration is greater, so we would call this solution acidic. Here let's solve for OH minus. This is equal to Kw over H3O plus concentration, which is 1.0 times 10 to the minus 14 divided by 1.0 times 10 to the minus 7. And you may know this already, but it comes out to be 1.0 times 10 to the minus 7 molar. Okay. Here the H3O plus and the hydroxide concentration are exactly equal, so it's neutral. Doesn't matter what those values are. If they're equal, we call the solution neutral. Okay. For pure water at 25 degrees Celsius, that's the concentration. For part E, similar type of thing here. We solve for the hydroxide concentration. Kw divided by the H3O plus concentration. Plugging in our given values. Gives us, after some calculator work and rounding to two significant figures, 1.2 times 10 to the minus 10th. And if you look at the concentrations here, it looks like H3O plus is greater, so we would label this solution as acidic. Okay, thank you for watching.